The next case is looking at NPV. So just as a brief reminder, NPV is how much profit would I make if I consider that money now is worth more money than money a year from now. And you'll recall this formula where we have net present value equals the sum of the cash flows discounted back at some discount rate. And so one of the things we want to notice is that if the NPV is positive, that means the cash flows overall, including our investment, based on the yield that we need from our investment, is greater than our required yield. So positive is good, which means we make more than our minimum. Negative NPV is bad, which means the project cash flows do not justify our investment. NPV equals 0 means it exactly equals our target rate of return, and although it's pretty small difference or marginal difference, we may choose to still do the project because it does meet exactly the minimum threshold for our project. Excel, this is a quick refresher, and I don't want you to feel insulted because we've done this a few times, because there's a very, very common mistake made here. So let's look at this hypothetical cash flow of T0, 1, 2, 3, with 2 negative cash flows and 2 positive. The thing you have to remember is the net present value always starts with T1. And T0 is not part of the NPV function. So the way we would figure out NPV is really broken into 2 sections, and you could put it in one cell, or as we do here, just to break it out to make it very clear, they're 2 distinctly different pieces of the NPV calculation. First, let's do the NPV. In this case, equals NPV, discount rate of 0.09, and we're going to do years 1, 2, and 3. Times 0, we're going to put as a negative 987 to be offset against the 1,620 as the NPV of the positive cash flows. So the net is 633, positive sign. So that it's a positive sign means it's a go in terms of project approval, or at least meeting project minimums. If it's exactly 0, it means it exactly meets our rate of return. So 0 is not bad. That's a common misnomer. If it's negative, that's bad. It means it does not meet our target return, in this case of 9%. All right, so we'll go approach number 2, discount rate's 10%, and you'll recall equals NPV, and I'll do it the slower way, breaking out the components. So 10% is the rate, and I'm only going to grab years 1 and beyond. And then I'm going to show that there is a negative cash flow of 100, and so the net present value is $18. All right, at least it's positive. So let's do the same thing here for project S, and so equals NPV, open parens, we want the rate 10%, comma, shade the range for T1 to the end, close parens, enter. So 119, again, we have to consider the initial outlay, and the net present value is 19. This amount versus this amount. So now we see that in the first case, I guess we should stick to our approach. In the first case, L was better. In the second case, now we're seeing that this one is better. This one's now blue, and this one just turned red. Okay, so we have a difference of opinion here. Now, if we do NPV at a discount rate of 10%, we'd rather do project S. And that's because money sooner is worth more money than money later. And here the $70 is front-loaded in the S, whereas the $80 is back-loaded on the L. And that's kind of the reason that it flipped on us, where it was just a simple summation or the total for the cash only. Now when we consider time value money, we're weighting it based on the discount factor, what we call the rate, 1 over 1 plus the interest rate raised to the power of years. Right? That's essentially what NPV does for us for each of the years in the cash flow range. All right, so now we're going to go to the next step,